In this video, we'll compare the Excel dynamic array and the Google Sheets array formula. We will use the SINE function and its matrix polynomial regression. Begin with the function of the SINE. So this is equal to SINE of the x values. SINE of the x values. And here you have the polynomial and the SINE, the trend line and polynomial of the SINE function. We'll do the same with Google Sheets. Array formula, SINE of the x values. And here you have the trend line and polynomial. Next we continue with the Linus matrix. So this is equal to the x values raised to the power (0 to 7). In the Excel dynamic array, there's an error because it does not recognize that any number raised to the power 0 is an error. So we correct that. So any number raised to the power 0 is 1. So if write the if statement, if this is 0, then 1. Now it's corrected. We do the same thing with Google Sheets. Array formula of the x values raised to the power 0 to 7. There's no error in Google Sheets. Now we can complete the p-generate inverse. We begin with the transpose of the Linus matrix. Same thing with Google Sheets. We also use transpose of the Linus matrix. Now we continue with the, this is multiplied by itself, so mmult of the transpose with itself. There's an error because you need to enter the closing parenthesis. Now there's another error. We remove the apostrophe. Now it's corrected. You can do the same thing with Google Sheets. So we just multiply and mult of the transpose with itself. And so it's easier with Google Sheets. We continue with the minverse now. So this is now minverse. To get the inverse, minverse. And you still have to, there's a problem with Excel. You have to remove this and close the parenthesis. Now it's corrected. Now we go to Google Sheets, minverse. And enter. Even if you don't put a parenthesis, it will automatically calculate. Now you completed the p-generate inverse. We continue the p-generate vector. So we begin with the transpose. You have to click this of the Linus matrix. Then enter. And multiply it with y. So that's mmult multiply this with y. Here's another problem. So we have to close the parentheses. Now that we completed the vector, we do the same thing with Google Sheets. So equals transpose of the Linus matrix. And multiply it with y. And multiply this with y. Our y is sine theta, or sine x. These values in Google Sheet is the same thing as Excel. Now we can calculate the coefficient. And of the P-Gerina inverse and the P-Gerina vector. We'll do the same thing with Google Sheets. And the P-Gerina inverse and P-Gerina vector. So these values, the coefficients, are the same as the Excel. Now we can calculate y hat, which is n of the Linus matrix and the coefficients. We'll do the same thing with, so you have now the equations. They're overlapping, but they're the same. We do the same thing with the Google Sheets. So this is equal to n of the Linus matrix and the coefficient. These values are the same, and their coefficients are the same. This completes the use of Excel's dynamic array compared to Google Sheets array. We're using the SINE function and its matrix polynomial regression.